Hey everyone, Ben from JangaFX here. Today is ground fog day. We're going to be looking at how we can use EmberGen to create a misty ground fog effect. And it's actually pretty simple to get set up. So first thing I'm going to do is I'm going to get rid of a few of these things that we don't need. Keep it really simple to begin with. Let's change the size of our domain. That's this bounding box that contains our simulation. I want something that's 480 by 480 by 64. That's something that's far wider than it is tall, because we want to confine this effect to the ground. Don't worry too much about this little guy here. It's going to change in a moment. So by changing the size of our domain, we are restricting everything that EmberGen has to think about to this small area towards the ground. If we were to have a domain that was, say, 480 high, we'd be forcing EmberGen to worry about everything else that's happening up here. And we don't need that. We just don't need it. So we're going to keep it down 64, apply that resolution, and that's going to keep things nice and snappy for EmberGen. So now let's create a shape that's going to feed the emitter that creates our ground fog, and that's not going to be this torus here. We're going to want to change this. So let's go to our primitive shape, change it from a torus to a box. That's not very good either, but we're going to change the shape and size of this. I'm going to make it 0.1 high. I'm going to bring the edges of this out to the ends of our domain. Now, currently it's giving birth to a lot of fire and fuel and heat, and we don't need that. All we need is the smoke. So let's pause, go into our emitter node, into our emission tab, fuel emission, change from add to no emission. Smoke emission, leave that as it is, but our temperature, no emission, that seems much better. So now when we reset with R, hit play, we're just giving birth to some smoke. It's all going to look very, very flat and solid, and that's because there's no forces currently in this simulation to push it around a little. So let's add some noise and see what that does to it. We're going to pull out a pin from here and drop in noise. So when you add forces to the simulation, these are like global forces, and they seem greatly amplified compared to the forces that you can add to an emitter. And that's because those forces are kind of masked by the shape of this emitter, so their effect is sort of reduced to an area. But with these guys, they apply to the entire simulation. So if we just leave it at default and hit play, we'll be able to see what that's doing to our smoke. And that's crazy. We don't need that. We need this to be quite subtle, really. So let's up the scale to say 30. Bring the amplitude down to maybe 0.2. That animation speed, I tend to roll with quite slow animation speeds. 0.2 for that as well. And that's still a little bit crazy, but that's because this noise is pushing this smoke around in all these different directions, and there's actually quite a lot of speed to it. So let's change the properties of the simulation so that the smoke weighs more and hugs down to the ground a bit more. Over into our simulation node, we've got force. So buoyancy, we can just get rid of. Even though there shouldn't be any heat, so there shouldn't be any buoyancy anyway, I'm still taking that down to 0. Our smoke weight, let's whack this right up. And it's going to fall down to the ground. Now, once we've done that, you can see that at the edges here, the smoke's kind of hitting the edge, and then it seems to just sort of disappear. So it's hitting the bounds of our simulation, and then I think it's, in a way, kind of falling out. So one way that you can contain what's going on here is to play around with these guys, these solid walls. So watch what happens to the overall look of this once we start turning these on. These are going to make these 4 walls around the perimeter of our simulation, make them solid so that things can't leak out. Alright, I like that, because now it doesn't feel like things are sort of falling out of our simulation. There's still a lot going on here, so we're gonna really make it quite subtle. And also another thing I'm gonna do is I'm gonna fade this smoke out before it gets to the edges here. So let's go to our volume processing node, slicing mask, and we're gonna look at the wall width, okay, for everything except the top and bottom, so for each of the walls around the side here. So that's this guy here. I'm gonna go with, let's say 15%, tab 15, tab 15, tab 15. And that just gently smooths things out a bit so we don't get that hard edge. Now, there's still a lot of movement going on here, so let's look at this. Okay, let's calm it down a little bit. So I have firstly gone to the emitter. Rather than giving birth to smoke at a rate of 100%, as it was here, we're going to give birth to it at, say, 25%. Thin it out a little bit. The second thing I did is I went over to our simulation node And I used, it's a trick I've used before. I go to dissipation and I tell the velocity dissipation to be something in the middle, 50, 64%, something like that. And all that does is that saps away the energy and the movement from it, unless it's directly being manipulated by a force like our noise here. So this noise is happening underneath, but that motion doesn't carry on. You know, once this smoke has been pushed, it sort of slows down again. So that's going to be quite useful once we bring in the next bit, which is Vorticles. So that's another global force that we're going to use. Bring these guys down here. You can find your Vorticles at the bottom here. And it will appear pretty crazy to begin with because these things are pointed in all kinds of different directions. They've got a really weird lifespan. So we're going to play with the settings for this. And the kind of look I'm after is I kind of want sort of whirls of smoke, a bit bigger than what we've got here. These are quite small. I want them to all be sort of oriented upwards so that we've got like a flat circle that spins in this smoke. And you'll see what I mean in just a minute. So let's click on our node here. 50 is a few too many. Let's go with something like 12 because we're going to be bringing the size up. Okay, so to stop them sort of moving around and swiveling, I'm going to put orientation damping all the way up. So as they get born again, you can see that they're all sort of straight and pointing up. This is good. And that's dictated by this here, orientation. So Z is 1. Just means point upwards. And you can obviously add 1 there. That all starts to point over in sort of like a 45-degree angle. But we don't need that for now. We're just going to stick with sticking straight up. Let's change the size of them. And you can find that here under size. So you have a minimum radius and a maximum radius. I'm going to go for, let's say, 30 and 50. And they'll be much, much bigger. Okay, that's cool. But maybe they're spinning a little bit too violently for me. So let's change the velocity that it's pushing and twisting with. Okay, that's pretty good. I'm going to turn off the noise just for now and reset, because the noise there was kind of detracting from what I was looking for. So I was finding it hard to see what was going on with these Vorticles. I'll make them a little bit bigger as well. So let's find out that. So we've got our minimum and maximum. Let's bring this right up to say 100-ish. That's a bit more like it. But this smoke is also not hugging the ground like I want it to, and that's probably because the location of this primitive shape here. So let's check this out. Let's drop this back down to 0. It should be much closer to the ground. There we go. That's what I was after. I think what I might do is tell these Vorticles to sort of push downwards and into the ground, and that should force the like these cavities outwards a little. So I think we're going to have to work in minus numbers here. And let's see what happens from the side. Maybe I'm going to drop down the number of them as well to say 6. All right, it's the right direction, but it's way too strong. Let's just go with minus 2. Okay, that looks good to me. So now I'm going to start mixing that noise back in. So let's turn them back on. We might have to bring the amplitude back up. So let's try 1. And if it's too noticeable, see like this, then you're going to want to drop it back a little bit, because that's really destroying what's going on with the Vorticles. So let's say 0.2 maybe, reset. Okay, I'm pretty happy with that, because it just adds a little bit of bumpy interest there. Now, one of the fun things that you can do with this noise is you can mess around with the bias, and that is akin to kind of running this noise through your volume, but in a direction. Right now, it's static. It's got moving parts inside it. It's animated, but as a whole, this noise doesn't move in a direction. But we can add that. Let's add 1 to Y and see what happens. It's pushing the entire noise field in the direction of Y positive. And that's already given us something fairly interesting, because you could use this almost as something like a falling dust sheet, or maybe a waterfall if you shaded it appropriately. Let's bring that down. And then let's also, I've got an idea. I've got a crazy idea here. Let's add a pin out for bias here, and then let's put it into an oscillator. It will go crazy to begin with. Okay, so it's running a function that's just moving the noise bias in all of these different directions at once. So let's pause it just for now. Reset. We only want to move it in the Y direction. So I'm going to keep Y as minus 10 and 10 there. But I'm going to set these guys to 0, 0, 0, and 0. Let's see what that does. Okay, it's a bit more like it. See if you can guess where this is going. I'm also going to slow it down. So we want our frequency here is 1 Hertz. Let's pop it down to like 0.1. And it's actually moving kind of too fast. So let's go -1 and 1. Reset. So it moves that way a bit. And then it moves this way a bit. And that's pretty cool. And the whole time it's got these vorticles that are creating these little puddles of disturbance. And that's pretty cool. Let's shade this. Let's make this look like it's a fluid. All right, that would be fairly interesting to look at. So let's go over to our shading node. We've got smoke. And currently we're on a color ramp here. So let's go exposed color gradient. It will change color initially, but we can pull this pin out here, bring up a gradient, and then let's bring up, I'm gonna steal the color of this water. But first, I need to be able to get to that EyeDropper tool. So we're going to click on this and we're going to sample. I'm going to hold down the mouse button and I'm going to drag across this watercolor. I'm going to go from a dark spot through to a light spot. So let's go from here, clicking and holding all the way through, and we're going to end up on something white there. All right, cool. So we've taken on the color of the thing that we were just looking at. That's like, I'm gonna try something slightly different. Let's go all the way along the bottom here, clicking, holding all the way across, and then let go. I like that. I like that much better. So you've got interpolation for this. So for each of these steps, EmberGen's shader is sort of fading in and out between these colors, but you can mess around with that. If you go with the constant, it's just going to be a hard edge. You might not be able to see it while it's in motion or while you're too far away, but it gives you much more of an edge between these colors. So, mess around with these and see if there's something that you like. Kind of like how this OKLab one looks. Note that you can, if you find a gradient that you really, really like, you can export it. And you can then, in a subsequent project, you can import that gradient and reuse those colors, which is pretty handy. And if at any time you just want to shake it up, try something different, bring up another picture somewhere, grab the EyeDropper tool and just drag across and try a few different variations of, the way that you're going across an image, because you can pick up different colors at different points along this graph, and that can really change how your shader looks. Okay, I think our wave thing's pretty cool. What else could we mess around with? Okay, cool. What I've done is I've brought in another noise force that's also global, and that's just pushing things around in a slightly different direction at a slightly different size. You can get some pretty nice random sort of flow effects that would absolutely suit some kind of Halloween spooky scene. If you had this dimly lit, that would look quite nice. And then of course you've got loads and loads of control over how thick the smoke is being displayed, let alone how thick it's being produced. So we've actually got 25% rate here per second. If you up this to say 100, it's going to look quite a lot different. Let's reset this. It's actually quite a bit nicer, I think, but it looks like it's so thick that it's blocking a lot of the light on the floor. And if we turn our ground back on, yeah, we can't see it. So what I would probably do in the emitter is go back down to 25% and then adjust the display of that smoke. Bring up our ambient here. That's a bit more like it. So in our smoke tab of the shading node, we've got control over density here. So if you don't want all of these really wispy bits, you want something maybe a little more twisty, a little bit more stylized, you could say bring this up to 5 or even 10, and that would like exterminate all of the really thin bits. It's like having a cutoff, like a low pass or a high pass. See what it does there? So it gives us, the thicker parts and displays those. And with those guys, you can amplify how thick they are with this smoke density scale. So if we bring this up, it's going to make them thicker. So you could very quickly get quite a stylized look. And this, in fact, would probably lend itself quite well to one of my favorite bits over on our scene node. So under style, you've got realistic, but I really, really, really like this anisotropic setting here. So by default, you click on it, it looks really weird, quite blotched out. But if you dial it down a bit, say to 1.5 here and 1.5 here. It's not far off from how it looked originally, but it's got something added to it, and it's just sort of slightly smeared and things are slightly elongated. I do that quite often for fire effects, and it just sort of helps with those edges. And just a heads up that there is another way to scroll the movement of this as well. If you can think of like a neat use case for it, you've got the Advection offset inside of your simulation. So if you click on the simulation tab here, you've got this offset here. So that would also, let's go in X direction, let's go ham, go with that. There we go. So that wouldn't be any use to me, but maybe what would be useful is, let's say -2. There we go. So that's just going to globally push things up. The difference between doing it this way and doing it with noise is inherently lumpy. You know, there's noise to it. Whereas this way, it's much more straight. You know, you get a much more smeared result because it's just kind of linearly pushed up. So that can help to sort of stretch things upward. Let's bring something like really, really small into there, just to help elongate some of these tendrils here. And you know, there's probably a bunch of different ways that we could use this setup. Let's take our domain back up to a bigger size. Let's go 480 again. And if we're looking straight down, you know, you could use something like this to emulate what you see on those high-res close-up pictures of like Jupiter's surface. In fact, we could use our color gradient here and a picture of Jupiter. And let's grab some of this, clicking and dragging. And obviously, you know, in these clips you see in sci-fi shows and movies and stuff, quite rightly, because the scale of Jupiter and planets like Jupiter is so massive, you'd never really realistically see these clouds moving, at least not very fast at all. So we'd have to do something about this here. So remember that thing I say about, you know, never messing with time control by too much? If you take this too far away from 60, then you get, you know, quite unpredictable results in the way that noise works and things animate and combustion works. But in this use case, we're not combusting anything. We're just moving some smoke around. So let's mess around with it. Let's bring it up to say like 240, something like that. And it's going to really slow things down. But you would want to change a couple of other things. Namely, our Vorticles are moving things way too quick. So let's have a look at that. And that's going to be our twist velocity here. So let's go 0.1 and 0.5. See how that works out. I feel like we'd actually need a lot more smoke. So let's go back to our volume emitter. Let's bring this up to 75. And maybe, in fact, bring this down to 120. There's all these different values inside of noise that have some movement to them. So we've got our bias here. Let's turn that off. In fact, let's get rid. Okay, that's all right. We've got this other noise here. So we've got an animation speed there, this amplitude. That's okay, actually. And what we do have on Jupiter, not that I'm an expert, let's see if we can emulate some of this banding. Maybe not the eye of the storm, but the banding we can probably do with a line force. Now, you bring it in and it's already pointing up. So what we want to do is to change the orientation of it. So let's rotate around X, say 90 degrees. That's good. And then it's going to be globally pushing everything in a direction. Let's bring in some fall off. Something like this. Restart. That's pretty good, but let's make it bigger. Let's say 10. And we're going to bring this guy over here. And we're going to make a few of these, and we're just going to orient them differently. And we have to do, rather than rotating in 180 degrees, let's just put a negative on this push. Okay, it's pretty good, but I would slow it down. So maybe minus 0.5. And for the other one, 0.5. And we're going to copy these guys, hook them up, pop one there, and this one over here. So we've got some of these sort of whirls and eddies coming up here, like little air currents that are just occurring between these two streams coming from the line forces, and that's pretty cool. I quite like that. I think you can actually see some of that happening in real life over here, you know, all this turbulence. Maybe we can amplify that a bit. If we go into our vorticity, currently got 5% vorticity intensity, and that is the small vorticity. But if we bring up the large to say 20 or something like this. That's pretty neat, but maybe we can mask it. So there's a constant mask of 20 there. Let's take that off. And a velocity mask, let's bring that down to say 50. So it's all just a little bit less intense. We've still got our movement. It's pretty good. These things that appear to be staying very, very still. Okay, these are likely coming from the noise that we've got here, and we've slowed all that right down. So let's move some of that animation speed back up. We should find that those things don't stand still anymore. All right, so we've seen how we can use a simple volume emitter situated close to the floor, and we can go through a bunch of different looks. And they range from, some simple whirls of mist on the ground to something that looks a little bit like water. And we sort of simulated some waves almost using the oscillator node here. Then we took that up a notch and we sort of viewed from above what you could easily use as some kind of close to Jupiter scene. And we've introduced some movement into this by putting these various line forces with fall off pointing in different directions. And then we've also looked at how we can use the EyeDropper tool here to grab colors from an external image, something outside of EmberGen. Maybe you found a reference image that you really like the colors in. You can go and grab them now. And that also works for fire, so that's really good for looking at different pictures of explosions and fires and sampling colors from those. And you'd be surprised how good some of those results can be. So that was a quick tutorial on a couple of different ways to get ground fog looks, and how you can use them for more than just ground fog as well. It's all about the forces and the colouring really. I'll make the preset here available for you to download, have a mess around with. I'll probably do a couple of different versions, so we'll do one for this, this orbital cloudscape, and one for the water kind of scene as well. If you get any questions, shout out on Discord or find us on Twitter. We'd love to jump in and help out whatever you're doing. And until then, I'll catch you in the next video.